This video presents Pyholmes, a tool for finding the root cause of a failing unit test in Python. Deep learning is increasingly prominent, but is more difficult to test and debug than traditional code. Researchers have created new tools to aid the process of testing and debugging deep neural networks. For example, TensorFuzz and DeepConsolic generate tests of DNNs in an adversarial fashion, seeking failing test inputs to reveal bugs. Mode debugs a known issue by selecting training samples to feed to the model with the purpose of correcting those faulty neurons. Causal testing is a technique that helps developers debug failing unit tests in traditional code, informed by counterfactual causality. Unlike existing debugging techniques for any kind of program, which help programmers understand what and where, causal testing helps programmers answer the why, such that they can produce fixes that address the root cause of the defect. This is typically done by finding slight variants of the original test that would have passed. This variation allows the developer to infer what exactly is being asked of their code that causes it to fail. With this knowledge, they can tweak their source code, rather than the unit test, to allow it to handle the input that it failed to handle before. DNNs are notoriously difficult to debug because they create their own abstractions for understanding data, abstractions that are rarely intuitive to humans. This black box problem makes it hard to understand why a DNN makes the choices it does. Causal testing's affinity for revealing the reason for failure would make it an effective testing approach for DNNs. However, there is no existing tool for performing causal testing on DNNs. The current implementation for causal testing, Pyholmes, is not particularly extensible to debugging DNNs, and is written for Java, whereas the most prevalent language for DNNs is Python. We introduce Pyholmes, a prototype tool that helps Python developers find the root cause of a failing unit test. Pyholmes presents the developer with a set of slight changes for their original failing unit test, which would cause it to pass. It is written in Python and is well suited to be extended to provide causal testing of DNNs in the future. We plan to soon extend Pyholmes in this way. A user calls Pyholmes on a particular failing test. Pyholmes runs the test as the user wrote it and records the execution path. It also searches through the project folder for any other tests that use a subset of the same user-written files, functions, and classes as the original test, and call functions in the same order, regardless of what those functions' input arguments are. Pyholmes then creates slight variants of the original test and any similar tests it found. It produces variants by slightly perturbing literals in the test body, such as strings, integers, and booleans. This process of perturbation is called fuzzing. Finally, Pyholmes presents the user with a report of the 3 passing and 3 failing fuzzed tests that have the most similar execution traces to the original test. Suppose a user has written the function word2int, shown here. The intent of their function is to convert a single word to an integer unique to that word. One rule is that for 2 words that have the same number of letters A through Z, the word which occurs later in alphabetical order should result in a higher integer. The user wants to check if this rule holds, so they write a set of tests, including this one. This test makes the function produce integers for the words can't and door, and only passes if the integer for door is higher. However, the test fails, and the user is unsure why. They turn to Pyholmes to find the root cause of the failing behavior. The user calls Pyholmes, passing it both the file name of the failing test and the line on which that failing test appears. Pyholmes takes a few moments to run alternative fuzzed tests, and then returns the user a summary of the 3 tests that are most similar, which pass, and which fail. The user sees that in this passing test, the apostrophe has been removed from can't. From this, the user surmises that the apostrophe was the cause of the issue. The user has found the cause of the original failure and is done using Pyholmes. They can now fix the issue in whatever way best suits their project. They might add a precondition to word2int, requiring its input string to only contain alphabetical characters. Or they could adjust the function's specification and implementation, making it skip over non-alphabetical characters, such that can't with an apostrophe and can't without an apostrophe would evaluate to the same integer. Thanks to Pyholmes, a user can rapidly obtain clues about why their unit test fails, allowing them to debug the issue it uncovered more quickly.